Good day, ladies and gentlemen. You are all welcome to First Assembly Conference of the Africa Wedding Federation, hosted in Cairo, in Egypt. I'm Adidi David Owarioro from Department of Wedding and Fabrication, Engineering, Technology, Delta State Polytechnic of Huachuku, Delta State, Nigeria. Co-presenter Oshiri Siri, Department of Metallurgical and Material Engineering, University of Nigeria, Usuka, Enugu State, Nigeria. Metals can be joined together industrially via brazing and soldering, and which are particularly popular in mass manufacturing. In order to create a construction with a certain capacity, two dissimilar materials must be joined together using specific method. Excellent quality of two different kinds of material are present in the junction structure of a dissimilar materials. And this can also attribute to a manufacturing method and technology called welding, using heating, high temperature or high pressure to combine with metals or other materials. And brazing, pressure welding, and fissure welding are three basic ways that welding can be accomplished to achieve a good joint. In this manner, joining process can easily be classed as welding, brazing, and soldering. Brazing and soldering is melting of filler rod only. Brazing have a high temperature using brass filler material, and normally the joints are stronger. Soldering is using lower temperature, thin lead filler material, while the joint made by soldering is relatively weak. In welding, the melting of filler rod and the base metals, both joint inexpensive parts to form a complex product. There are numerous types of welding joints, but we got to limit ourselves to 5 basic welding joints, which are butt joint, corner joint, T-joint, lap joint, and edge joint. In brazing, consists of the steel base metal plus brass filler material, which is used as lower temperature than welding, retain heat treatment if present, minimize grain growth, strong but slow, careful preparation and cleanup. Furnace brazing is easily automated, and it consists of torch, base material, and the flux and the filler material. In shaded metal arc welding, which is MAO, also called stick welding, is older, simple technology, and the electrode is also the filler rod. It is used for steel, strong weld if done properly, but often not. Very high heat input, good for thick parts, bad for grain growth and distortion. It consists of a welding machine, the welding lead, and the return leads, and the stick electrodes. We also have the gas metal arc welding, which also we call either MIG or MAG or GMAO. It's a complex mechanism, but simple to perform and easy to automate. The electrode is also a filler rod, feed continuously for a spool. It melts in the arc for steel or aluminum. Low skill level can achieve good weld, and it consists of the welding gun and the simple welding machine, and also the feed control system, and also wire feed drive motor, and the shading gas source. The welds that are done with GMAO are often very good welds and little bit free of defects and flux. TIG weld, which also we call GTAO, is also consists of an electrode called tungsten, which is not consumable, and the filler rod is separate and feed manually, and the high skill level required to achieve good welds and difficult to automate. Low heat input, small weld bead, distortion and grain growth are also minimized. It consists of a welding torch and the inner gas supply, then AC or DC welding machine, and the water drain and cooling water supply system. Weld done with TIG welds look good in face appearance, and little defects you can spot from the weld made by TIG depends on the skill of the welder. We also have resistance spot welding, which no filler rod is required. Electrical current is passed through heat through metal under pressure. Low skill level required, easy to automate, low heat input, and no weld beads. Distortion and grain growth are also minimized. Distortion from welding process are non-uniform streakage of weld bead and difficult to maintain alignment, and solution for this is rigid features precompensate for warpage and loose tolerance. Weld bead profile can be convex or concave. Solidation of motive bead leads to shrinkage, and shrinkage of a concave bead leads to tension on the surface, tend to cracks, and shrinkage of convex bead leads to compression on the surface and does not crack. Generally, slightly convex bead are preferred. Weld defects and flux are underfill, occlusions, crack, incomplete penetration, porosity, overlap, undercut, etc. Welding flaws or defects on incomplete penetration, not enough heat input, can see on your slide the difference. Wire brazing is a journey process in which a filler metal is melted and distributed by capillary action between the fay, which is the contact surface of the metal part, bead joint. The base material does not melt in brazing, only the filler material melts. In brazing, the filler metal has a melting temperature, which is the liquidus above 450 degrees centigrade of base metal to be joined. The advantage of brazing. Brazing can be used to join a large variety of dissimilar metals, and pieces of different thickness can easily be joined by brazing. Thin wall tube and light gauge sheet metal assembly not joined by welding can be joined by brazing. Then a complex and multi-component assembly can be economically fabricated with the help of brazing. In a sensible joint area which could not be joined by welding or by gas metal or TIG welding or spot welding or seam welding can easily be joined by brazing. Welding flux are low melting temperature, low viscosity that can easily be displaced by the filler metal and facilitate wetting and protect all the joint and solidification of the filler metal. The thin tube and light gauge sheet metal assemble not joined by welding can be joined by brazing, and complex and multi-component assembly can be economically fabricated with the help of brazing. Then the torch brazing is the flush is applied to the part surface, and a torch is used to direct the flame against the work in the vicinity of the joint. After the work part joint area have been heated to a suitable temperature, a filler wire is added to the joint, and usually in a wire or rod form. Fuel used in torch brazing include acetylene, propane, butane, and other gases with air or oxygen. Torch brazing is often performed manually, and skilled worker must be employed. Other types of brazing are furnace brazing, induction brazing, resistant brazing, deep brazing, and infrared brazing. Soldering is similar to brazing, and it can be defined as a journey process in which a filler metal with a melting point liquidus not exceeding 450 degrees centigrade is melted and distributed by capillary action between the fay surface of the metal to be joined. As in brazing, no melting of the base metal occur, but the filler metal wets and combine with the base metal to form a metallurgical bond. A filler metal called soda is added to the joint, which distributed itself between the closed fitting part, soda, alloy of tin and lead, and the tin is chemically active at soldering temperature and promote the wetting action required for successful joining. Principle of soldering. Soldering is very much similar to brazing, and its principle as simple as that of brazing. The major difference lies with the filler metal. The filler metal used in case of soldering should have the melting temperature lower than 450 degrees centigrade. The surface to be soldered must be pre-cleaned so that these phases of oxide and oil are eliminated. An appropriate flux must be applied to the sphere surface and the surface are heated. The filler metal called soda is added to the joint, which distribute between the closed fitted surface, and the strength of the soda joint is much lesser than the welded joint and lesser than brazed joint. The different type of sodas are used as a filler metal or filler metal compositions. The tin, lead, silver, and zinc antimony type, and they have the different composition in percentage, like tin of 60 and lead of 40 has a melting temperature of 188 degrees centigrade, which is used for electric circuits. Then lead of 96 and silver of 4% have a melting point of 305 degrees centigrade, and the joint making at this make at elevated temperature. Then tin of 50 and lead of 50, which have a melting point of 199 degrees centigrade, is used for wire joining. Then tin of 40 and lead of 60, which has a melting point of 208 degrees centigrade, is used for automobile radiators. Then tin of 91 and zinc of 9%, which have a melting temperature of 200 degrees centigrade, is used for joining of aluminum wires. Then tin of 95 and antimony of 5%, which have a melting point of 238 degrees centigrade, is used for plumbing applications. Type of soldering fluxes are the organic fluxes and inorganic fluxes. And organic fluxes are either rosin or water soluble. And the materials, rosin is used for flux, as for wood gum, and other rosin which are not water soluble, which are organic fluxes, are mostly used for electrical and electronic circuit making. These are chemically unstable at elevated temperature, but not corrosive at room temperature. Summaries. Soldering and brazing are the two allied processes of welding. The major difference between them is huge amount of heat, which is required in case of welding. Low amount of heat is needed in case of brazing, and very low amount of heat is consumed in case of soldering. Welding gives the high strength joint which are capable to bear a heavy load, and a joint made by brazing are relatively weak, and soldering joints are very weak to bear the load, and generally soldering is used to make electric contacts. Different type or method of brazing are described in this unit. There are no different variety of soldering method. Only the soldering material called spelled or has its different variety according to application. Thank you for your listening.